everybody. One of the questions that a lot of your classmates have been raising is to offer some help with these questions like the one you see on the screen that are offering you to fill in the details of a partially complete source table. And so to do this, you oftentimes have to glean a lot of information from the question itself, from what they tell you in the sentence format, and then you combine that with what you know about how these various cells in the table are calculated to basically fill it in. So I'd like to walk you through 3 different versions right now, and hopefully this will be of help to you. This first one that you see on the screen is for a one-way analysis of variance. I know it's one-way analysis of variance from the source table because you can see here I only have the between treatments and within treatments as possible sources of the variance. So when I read the question, it says the following table shows the results of an analysis of variance comparing 3 treatment conditions with a sample of n equals 7 participants. So the key things that you're going to get out of here are the number of treatment conditions and the n equals 7 participants. So those are the key values that you need from up here. And so based upon that, you know a few things. You know that the little n is 7, so that's great. Because there are 3 treatment conditions, that means you know that k is 3. And so what that tells you then is that your degrees of freedom between treatments, which is k minus 1, must then equal 2. Okay. The other thing that you know is if there are 7 in each condition and 3 conditions, then your big N must be 21, right? 3 times 7 is 21. So your degrees of freedom total is going to be big N minus 1, right? So your degrees of freedom total is going to be 20. Once you know that, you can fill in this degrees of freedom because you know that the degrees of freedom between treatments and the degrees of freedom within treatments has to add up to equal the degrees of freedom total. So this value must be 18. Once you know that, because you know that you can get sums of squares, actually let me say that the other way around. Sums of squares divided by degrees of freedom gives you mean squares. So you can go backwards and say mean squares times degrees of freedom must give you sums of squares. So this value must be 36. Once you know that, you know that the sums of squares total is just what you get if you add those 2 numbers up. So that's 56. And you can come out here and get the f value as well, and that is the mean squares between divided by the mean squares within. So this f value is 5. Okay, so that's it for a one-way ANOVA. Let's now switch over and look at repeated measures ANOVA. Okay, so the same thing. We're going to read the question here and glean a lot of information from that. So it says a researcher is evaluating customer satisfaction with the service and coverage of 2 phone carriers. Each individual in a sample of n equals 16, so there's one piece of important information, uses one carrier for 2 weeks, and then switches to the other. Each participant then rates the 2 carriers. Okay, so there's lots of places you can get that information that there are 2 carriers, but that's a key piece of information there. So you know that n equals 16, okay, and you also know that there are 2 levels of the treatment, okay, because it tells you that there's 2 carriers. So based on that, sorry I didn't leave myself an extra line, you know what n is because n must be k times n, so n must be 32, okay? Okay, so once you know that, then you know what degrees of freedom total is because degrees of freedom total is just big N minus 1. So degrees of freedom total must be 31. We can also get degrees of freedom between treatments because that's k minus 1. We know we have 2 treatments, so this must be 1. Once we know that, then because these 2 degrees of freedom have to add up to this degree of freedom, that means we know the degrees of freedom within treatments must be 30. Okay. We also know degrees of freedom between subjects because that's just the number of subjects minus 1. Alright, so this is little n minus 1, so that must be then 15. And then because these 2 between subjects error, degrees of freedom for between subjects error and degrees of, I keep saying that wrong, because degrees of freedom for between subjects and degrees of freedom error have to add up to equal the degrees of freedom within treatments, that means we know this is 15. Okay. Once we know that, we can do a couple of different things. So for instance, we know that we need the mean squares error here if we're going to be able to solve for f. So sums of squares divided by degrees of freedom gives us the mean squares for error. And then working backwards this way, we know that the sums of squares between treatments has to be 8. Because 8 divided by 1 has to give me 8. Now I can go ahead and get the rest of this area in here, because we know that the sums of squares between treatments plus sums of squares within treatments has to equal sums of squares total. So this must equal 103 minus 8, which is 95. And then again, because these two, which I won't try to say again, have to add up to this one, that means that we know that this must equal 35. Now the only thing that we have left to do here is to calculate f. That's just the mean squares between treatments divided by mean squares error. So 8 divided by 4 gives us an f value of 2. Okay, so now let's switch over and do the two-way analysis of variance. So this one gets even a little bit more complicated, but we can do it. So here we know it doesn't tell us much about the design, it just kind of points us to the table, but it says the following table summarizes the results from a two-factor study. So two-factor, we know it's a two-way analysis of variance. And then it tells us that factor A has 2 levels. Okay, that's for factor A. And we also know that factor B has 3 levels. Okay. The other piece of information we know that there is that, man, I'm fumbling, I'm sorry. The other thing we know is that they have separate samples of n equals 8 participants in each treatment condition. So each of the cells in this 2x3 design has 8 participants in it. So from all of this, we know a lot of things. We know that little a is 2. We know that little b is 3. We know that little n is 8. We can also calculate big N, because big N is just little a times little b times little n. So that's going to be 48. Okay, and when we have these pieces of information, this should be black because this is stuff we're solving for. When we have these pieces of information, we can do a lot of work here with the degrees of freedom. So if we know that little a is 2, then we know that the degrees of freedom for a is little a minus 1, so that's 1. For b, it'll be little b minus 1, so that's 2. And then a times b, we literally just multiply this degrees of freedom times this degrees of freedom, so that gives us 2. Now we know that the total degrees of freedom between treatments must be 5, and that's because this number has to equal the sum of these 3 numbers. It's also, if you think about it, we know that there are 6 total cells, so that the total degrees of freedom between treatments would be 6 minus 1 would give us 5. Okay. Degrees of freedom total is just big N minus 1, so that's 47. And then that makes degrees of freedom within treatments 42. Okay. Once we have all of that, we can start to incorporate sums of the squares and mean squares information that we have. We have this nice confirmation that we didn't make a mistake here, right? Because 126 divided by 42 is 3. Now we can work backwards to get this sums of squares. This must be 24, because 24 divided by 2 has to equal 12, right? And this one's a little bit tricky now. So to get this mean squares, I have to know that that mean squares, well, let me say that a different way. This value of f is equal to this mean squares divided by this mean squares, right? So the mean squares for b divided by the mean squares within treatments. So this mean square divided by this mean square has to give me 6, so that means this must be 18, right? And then again I can work backwards, so now 18 times 2 is 36. Now I know that these two numbers have to add up to equal this number, so 36 and 24 is 60, so that leaves 12 for right here. Now 12 divided by 1 going this way is 12. And then this mean squares for A gets divided by the mean squares within treatments. So 12 divided by 3 gives me 4. And the only thing I left out was this one. Sorry about that. So I would just add between treatment sums of squares with within treatment sums of squares, and that gives me 198. And that's it for that one.